When I was growing up, I heard of marijuana called the devil's lettuce, and I always found that extremely misleading. Like, Satan is a farmer now, and I mean, look at regular lettuce and marijuana. Which one would you put in a salad? It's obviously this one. Anyway, the perception of marijuana has been shifting a lot from my childhood. If you ask people on Reddit, marijuana can apparently treat pain, headaches, cure cancer, and even possibly bring back people from the dead. So, I wanted to take a look at a research paper which claims gray matter volume differences associated with extremely low levels of cannabis use in adolescents, which was posted in the Journal of Neuroscience on March 2019. A quick introduction. Almost 35% of American 10th graders have reported using cannabis, yet we still understand little about the long term health effects of initiation of cannabis use in adolescence. Gray matter is essentially the neurons of the brain, which maybe gives a whole new meaning to the gray stuff from Beauty and the Beast. The possible mechanism through which marijuana is causing these neurobiological changes is through the endogenous cannabinoid system, which includes regions such as the amygdala, hippocampus, striatum, and cerebellum, as this system mediates neural reorganization due to maturation. For the methods section, I know what you're thinking, and no, they did not give teenagers weed. It's unethical. Why? For the same reason you don't give a baby a pack of cigarettes. It would be a waste of a bag of cigarettes. Plus, it would be a better test bench to give them cigars anyway. What they actually did is recruit teenagers from 8 sites whose grandparents were all the same nationality as the participant to try and eliminate some variability. Of the teenagers they recruited, they split them into 2 cohorts. Cohort 1 had 47 participants, which reported low levels of cannabis use at base. We're talking about 1 to 2 lifetime instances. I'll call these people the triers, as they remind me of people who are down to try anything once. Cohort 2 was filled with 69 participants who did not try cannabis at age 14, but reported at least 10 instances of cannabis use by the follow-up 2 years later. I'll call these individuals the brownies. All individuals in both groups were matched with controls that had the same demographic information but had no cannabis use. They got their data on cannabis and other substance use through a self-report questionnaire. They then took these 2 cohorts and their controls and stuck them into an MRI machine to get scans of their brain. The participants took some personality and temperament measures to see if there are any correlations. Now for the results of this paper. The figure illustrates extensive regions of greater gray matter volume in the triers. Regions such as the bilateral medial temporal regions, which includes the hippocampus, amygdala, and striatum, were implicated. These regions are particularly relevant in addiction and substance abuse. When looking at the differences in symptoms of psychopathology and personality, sensation seeking and agoraphobia, which is the fear of places and situations that might cause panic, helplessness, or embarrassment, were higher in the triers than in the control group. For the brownies, there were no regions in which the gray matter volume differed between the future cannabis users and their matched controls. This makes the theory that increased gray matter volume makes people more likely to use cannabis improbable. When looking at associations between gray matter volume and future behavioral measures, they found that the baseline gray matter volume in the right temporal cluster was significantly greater for those cannabis users who went on to have higher levels of generalized anxiety. As to try and find possible mechanisms by which this happens, the researchers found significant spatial association between the magnitude of gray matter volume effects and CB1 receptor availability. In addition, gray matter differences between cannabis users and controls with the map of the CNR1 gene expression showed a significant spatial association. Some limitations are that the sample of people they took is racially and ethnically homogeneous, so further research needs to be done to generalize to youth from more diverse backgrounds. Substance use was using self-reported data, so the researchers don't have a standard dose units of cannabis or information on mode of use, such as smoking or edibles. In addition, the suggestion as to the mechanisms for effect is speculative since spatial associations were significant but small. My conclusions are this. A lot of research needs to be done regarding cannabis, and hopefully with many US states now legalizing cannabis, more experiments can be done. However, based on this research paper, it seems like any marijuana use during adolescence could have long-lasting effects on the brain. The best practice still seems to be, at the very least, avoid any drugs when your brain is still developing. Thank you for watching this video. If you enjoyed the content, be sure to hit the like and subscribe buttons as it helps me a lot, and I'll be releasing more videos over the next couple weeks. So with that, be sure to wear a mask and I'll see y'all in the next one.